Now we are moving for part B. Here, one of the things we will discuss is atomic number, mass number, isotopes, application of it, and isobars. Okay, dear? Atomic number. What is this atomic number? Atomic number says how many protons are there present in the atom. That is atomic number. So, it is denoted by the letter Z. Okay? We can say without proton there is no atom. Every atom will be having protons. Okay? With that we are arranging. According to atomic number, we are arranging the periodic table itself. See how it is arranged? In the order of atomic number. 1. Here 2 means in hydrogen 1 atom. Helium 1 proton. Helium 2 protons. Lithium 3 protons. Beryllium 4 protons, like that it is moving. So we are arranging it in the form of atomic number. So atomic number is represented by Z. Then we are moving for the mass number. Mass number is what? It shows the mass of the atom. As I told you, mass of the atom is mainly due to the sum of the mass of protons as well as neutrons. We are not considering electrons because mass of the electron is negligibly small and we are not considering it. We are considering the mass of neutron as well as proton. Is there any atom without neutron? Answer is yes. Hydrogen is not having neutron. If anyone is asking for the fill in the blanks, it can be, there is chance for this kind of questions. Okay. Who discovered neutrons, ma? J.J. Chadwick was a scientist who discovered neutron. Okay. These are the information I used to give in between. So the mass number is the sum of what? Sum of number of protons as well as number of neutrons. For example, carbon. Okay. Carbon is having 6 protons. Carbon is having 6 neutrons. So what will be the mass number? 6 plus 6, 12. 12 will be the mass number and we are representing it as 12 mu. 12 mu we will say. 12 mu. Okay, in this manner. Say aluminium. 13 protons and 14 neutrons are there. So how will we represent the mass number? Mass number as 13 plus 14. Are we expert in maths? It's 27. So 27 is the mass number. We are saying mass number in some other names also. Atomic weight is a mass number. Atomic mass is a mass number. If they are asking in that manner, the same is mass number only. Okay, ma? Because atomic weight is mass only. Mass number only. That's right. Okay. Now, notation of the atom. How we have to notate the atom? We should be able to notate the atom. How we are able to notate? For example, this aluminium itself. Aluminium. Or we are representing it as, commonly we can say X, Z, A. What is Z here? Z is atomic number. What is A here? A is the notation for mass number. What is X here? X is the symbol of the element. Okay? We have to write the symbol of the element. In the lower part we have to write the atomic number and in the upper part we have to write the mass number. Is it clear? See, aluminium. As we can say, Al. Here, how many protons, ma? 13. In the topmost part we have to write 27. In this manner it has to be. Did we get? Carbon. If we are representing carbon, it can be written as carbon 6. 6 plus 6, 12. Like that it has to be represented. Mass number is 12. This is the notation for the atom. Now we are moving for yet another thing, isotope. See, as I told you, this atomic number represents the number of protons. If the atomic number is changing, what will happen? Atomic number is changing, what will happen? The element itself will change. Because the number of proton represents the elements. If the atomic number is changing, the element itself will change. But if the mass number is changing, will the element change? No. It is the sum of number of protons and number of neutrons, which means the neutron number can be changed, and which makes the mass number to be changed. Okay. So what is isotope? Isotopes are the elements having same atomic number but different mass number. Okay. Same atomic number is there for the element, but the mass number will be different. These are called what? Isotope. Easily for you to understand, top means when we are notating the atom, in the topmost part change is there. It is not acceptable if you are moving, but for you to convenient I am saying you can learn in this manner. Isotope. In the top it is mass number, no? This mass number is changing. Isotope. Okay. For example, hydrogen itself. Hydrogen is having H1 because number of proton is 1. And the topmost there is, what is the mass number? Number of proton plus neutron. But as I told you, hydrogen is not having neutron. The top should be 1 only. Okay. Because number of neutron is 0 and the number of proton is 1. 1 plus 0 will give you 1. For deuterium, yet another isotope for the hydrogen. It is having same atomic number, but it is having 1 neutron. So 1 plus 1 will give you 2. 2 is the mass number. And for tritium, some will say as tritium, but I am saying it as tritium. Tritium is having 2 neutrons. That hydrogen is having 2 neutrons. So mass number is 2 plus 1, 3, while the atomic number is 1. In this manner, this is isotope. In the topmost part, change is there. Did you get my? It is easy for you to understand. Okay? Okay. We have seen hydrogen isotope. No? They are protium, deuterium and tritium. Same form for carbon also. Carbon 12 is present and carbon 14 is also present. But carbon 12 is much more abundant compared to carbon 14. Carbon 14 is abundant 0.1%, but carbon 12 is abundant much more. But in the case of chlorine having, for example, we can say chlorine 1735 is the normal chlorine, and chlorine isotope Cl 1737. Here chlorine 35 is present in 75%, while chlorine 37 is present in 25%. So what will be the mass number? Mass number will be the average of these two. Mass number will be the average of these two isotopes. Okay, ma'am? How we can calculate? 35 divided by 100 into 75 plus 37 divided by 100 into 25, because percentage of these two values will become the mass number. Okay, ma'am? So total will be 35.5. So this is the average. This is the average mass of chlorine. Okay. By this way, we are able to calculate for all the atoms. Similarly, when we are saying for the atoms having no isotope, if there is no isotope for the atom, what will be the mass number? Mass number will be the sum of proton as well as neutron. I have told you already. Based on that, much more questions you can expect. We can say sodium. Sodium is having atomic number 11 and number of neutron is 12. So what will be the mass number? They will ask in that manner. So atomic number is 12, which means number of proton is 12, and the number of neutron is 12. Then we have to add and find the mass number as 12 plus 11 is 23. Like that you can find. Otherwise they will give atomic number is 11, mass number is 23. What will be the number of neutrons? In that fashion, you can expect questions much more. Numerical questions. Also in the same manner for isotopes. What will be the percentage of isotope? That also we can expect when they are giving to which percentage it is existing. What will be the average mass? That also can be expected as the numerical question. Now we are moving for the application of this isotope. Isotope, we can say they will be having almost same chemical properties, but we can say still much more properties are there for the isotope which are different from the element. To say uranium isotope is used for the atom bomb creation or nuclear reactor it is used, and for cobalt is used for treatment of cancer. Isotope of cobalt is used for the treatment of cancer, and iodine isotope is used for treatment of this Goitre. Goitre for treatment they are used. These all things are application for isotope. Now we are moving to learn a new thing, that is isobar. What is this isobar? It is entirely opposite to that of isotope. As I told you in the top, if change is the mass number is changed, we can say the thing is isotope. What will be the isobar? In the bottom, if the atomic number is changed, it will be called as isobar. If the atomic number is changed, what will happen? I told you atomic number is the number of protons. If the number of protons is changed, what will happen? And the atom will be changed. Okay? But what will be the common? Mass will be common. So isobar is the thing which is having different atomic number, which means different elements will be but having same mass number. Is the thing clear for you? How can we learn? Isotope, I told you top change is there. Isobar, it is like the class. Children are from different families and they are coming to the class. It's a common, right? The base is from different families and they are coming to class. Or people are from different places and coming to bar. I'm not saying that. It will be much more easy for you to listen. It's not bar. Bar can be anything. It's not the liquor bar. It can be bar association. All these things can be this court. They are saying it as bar association. Whatever it is, in whatever manner you are learning, it's no problem. But to say from different place it is coming and coming to the same point. That is, for example, we can say calcium. Calcium is having an atomic number 20 and the mass number 40. Argon, atomic number 18, but the mass number is again 40. We can say that they are isobars. Did you get now? Is it clear? Mass number is same, atomic number is different. That means the element is different but having same atomic number. Let's see, same mass number. Okay? Is the thing clear for you? Now we have learned a lot in this chapter. It's the question time. Dears, this is the question time. The first question. Dash discovered proton. Who discovered proton? You can write the answer. Second is, write the notation for phosphorus having proton number 15 and neutron number 16. You have to write the notation of the phosphorus having proton number 15 and the neutron number 16. And the third one, sodium Na plus ion has completely filled K shell and L shell. Why? Na plus ion has completely filled K shell and L shell. Why? Thank you for watching.